My dear children, welcome to my channel Sudhir Chemistry. But today we are going to discuss from this alcohol, phenol and ether, the first topic about the alcohol. Alcohol, general form of the alcohol can be written in the form of a ROH. But this OH will indicate here as a secondary suffix. And secondary suffix for the alcohol, it can be written as a OL. But this alcohol, which one we wrote here it is classified in the following way. Let me tell you what are the classification of the alcohol. Classification of alcohol. But how this alcohol can be classified? But it may be a primary alcohol, it may be secondary alcohol, or it may be tertiary alcohol. But in this one, the first one, I want to classify it in the form of alcohol called as a monohydric alcohol. What is meant by monohydric alcohol? Alcohol which is having only one OH group is called as a monohydric alcohol. Let me explain you about this monohydric alcohol. Example you can see it here. CH3OH, monohydric alcohol. But it is a CH3 and CH, again OH. This is also monohydric alcohol. And one more I want to write here. This is a CH3, then CH3, then CH3 bonded with OH, monohydric alcohol, because it is having only single OH group and it is attached to the carbon atom beta. That carbon atom is a sp3 hybridized carbon. You can see all the carbon where it attached, it is a sp3 hybridized carbon. It is about monohydric alcohol. Second one is a dihydric alcohol. But a dihydric alcohol means it is having a 2 OH group. What is a 2 OH group? Let me explain you here. But here CH2 bonded with the CH2 and both the OH group is present on the adjacent carbon atom. It is called as a dihydric alcohol, and do you know this is called as a ethylene glycol. This will be called as a ethylene glycol about the dihydric alcohol. Next one we can say but here the monohydric alcohol which one we wrote in the aliphatic form. In this case one of the example I can write here. But here benzene ring bonded with CH2 and bonded with OH. I think you should know better here. Benzene ring having CH2 group is called as a benzyl and OH present over it called as a benzyl alcohol. It is a benzyl alcohol. And even you can see better OH which is bonded to carbon. This carbon also what? sp3 hybridized carbon. In this dihydric alcohol beta OH bonded to sp3 hybridized carbon, OH bonded to sp3 hybridized carbon. In the same way, we are having a trihydric alcohol. And do you know what this trihydric alcohol is called as a glycerol? It will be called as a glycerol. 1, 2 and 3. OH bonded to here, OH bonded to terminal carbon and OH bonded to this terminal carbon. But commonly it will be called as a, glycerol. But when we write the IUPAC name, according to the rule beta, compound is having more than 2 similar functional group, then we should write the name of the alkane. 3 carbon means propane. OH is present on 1, 2, 3. That means it is having a OH group present it called as a tri-OL. Propane 1, 2, 3 tri-OL. But here having these two called as a what ethane. IUPAC name I am talking. IUPAC name ethane. But 1, 2 di-OL is the IUPAC name. But commonly it will be called as a ethylene glycol. Commonly it will be called as a glycerol. At the same time, polyhydric alcohol. But I will discuss about the polyhydric alcohol. Poly means more than 3. It may be 4, it may be 5, it may be 6 and all. But here, example I will tell you that sorbitol and mannitol is called as a hexahydric alcohol. For this one, I will say beta, either it is a sorbitol or it is a mannitol. They all are the hexahydric alcohol. Means it is having a 6 OH group. But a 6 OH group means how to write here. I'll show you. It is a CH2 OH, then beta CH OH, This CHO is taken 4 times, 4 plus 1 5, and again CH2OH 6. This is called as a hexahedric alcohol, and it is also called as a sorbitol, or it will be called as a mannitol. But now you can see monohydric, dihydric, and trihydric, polyhydric alcohol. We'll see here OH bonded to the carbon, and carbon is bonded with no other carbon. This carbon is called as a primary carbon, and alcohol will be called as a primary alcohol. And do you know better? Primary alcohol denoted in the form of a 1 degree ROH. But a OH bonded to the carbon, and this carbon bonded with two more carbon. So this carbon is a secondary carbon, and alcohol is called as a secondary alcohol. But a OH bonded to the carbon, carbon bonded with three carbon. So this carbon is called tertiary carbon, and this alcohol called as a beta tertiary alcohol. So what we have? Primary alcohol, secondary alcohol, and even beta tertiary alcohol. Three alcohols are there, and in all the cases, our OH group is bonded to the sp3 hybridized, sp3 hybridized, sp3 hybridized carbon. But I am going to discuss with the one more called as a vinyl alcohol. Sir, what is mean by vinyl group? But a vinyl group means it is having CH2 double bond CH free bond called as a vinyl. You can see but this free bond is present on the carbon. Carbon is having double bond. So this carbon should be a sp2 hybridized carbon, and OH present on it called as a vinyl alcohol. But one more is called as a allyl alcohol. What is mean by allyl group? So we should know allyl group means it is a CH2, double bond CH, single bond CH2, and free bond. For allyl, minimum carbon atom 3 with one double bond. For vinyl, minimum carbon atom is 2 with a double bond. But in allyl, the free bond is present only on the sp3 hybridized carbon, and OH group attaches to it. It will be called as an allyl alcohol, right? So this is a vinyl alcohol. This is about the allyl alcohol. Now after that one we'll see beta. Now the after the classification of alcohol and all, we'll go with the nomenclature of alcohol. But after the classification of alcohol, just we'll go with the nomenclature part of the alcohol. That is the IUPAC naming as well as the common name of the alcohol. I'll write few compounds here, and based on that compound we'll try to write the IUPAC as well as the common name of this alcohol. For example, I'll start with this one, CH3OH. Then one more compound I'll write here as a, but it become a CH3, then CH2, then CH2, and then OH. One more compound we'll write here, it become a CH3, but a CH, then OH, then bonded with CH3. And one more compound we can write here as a CH3, then CH2, then CH2, then CH2, and then OH. Somewhat difficult example we'll take now. Instead of doing all these things, but I will take here CH3, then bonded with carbon, then CH3, here also better CH3 and OH. These are the few alcohols which one I wrote here. Chalo, we'll try to write the common name of this alcohol. But what is the common name of this alcohol? CH3 present it called as a methyl. So as one carbon is here, it will be called as a what? Methyl alcohol. That is a common name. But here how many three carbon are there? All the three carbon atom is in a straight chain. So N means normal, it is straight chain. 3 carbon propyl, N propyl alcohol. You can see beta CH3CH, then CH3. You know CH3CH, CH3, this group is also called as a iso group. And as 3 carbon is there, called as a propyl, and we can call it as a alcohol. Beta isopropyl alcohol. Here 1, 2, 3, 4 carbon in a straight chain. So N 4 carbon butyl, then it will be called as an alcohol. In this case beta 1, 2, 3, 4, and you know this is a tertiary carbon, 4 carbon present over it, but it will be called as a tertiary butyl alcohol. But we'll write the IUPAC name of this compound. How to write the IUPAC name? Rule we know. Compound containing one carbon So METH. But a single bond ANE. E replaced by secondary suffix OL called as a methanol. But try the IUPAC name of the second compound. But this IUPAC naming of the compound, it is only depends on the number of carbon atom present over it. So one carbon beta METH, single bond ANE, E replaced by OL called as methanol. But here OH present on the carbon will be numbered as a 1. So we can give the number 1 here, then number 2, then number 3. 1, 2, 3. 3 means I should write PROP, single bond ANE. But the last ka E replaced by OL because secondary suffix for the alcohol is OL which is present on first carbon. So 1 dash OL, or we can write beta 1 propanol, or we can write directly propanol. Here OH attached to the carbon, longest chain beta 1, 2, 3. OH is on second carbon and here 3 carbon is there. So directly write on beta 2 propanol, right? Because OH is on second, 3 carbon means propane, or we can write in this way also. See, PROP, prop, single bond AN, last E replaced by OL which is on the second carbon. So propane to OL can be written as 2-propanol. In this case, beta, OH bonded to the carbon number 1, 2, 3, 4. So I should write here as a 1-butanol. Beta, in this case, longest chain of the carbon, I'll select in this way: carbon atom 1, carbon atom 2, carbon atom 3. Second carbon methyl group is there. So name is beta, it is a 2-methyl. Then OH is also on second carbon and 3 carbon is there. 2-propanol. 2-methyl 2-propanol is the IUPAC name of this compound. We have seen beta. After the nomenclature, we are going to discuss about isomerism in the alcohol. Listen here. Isomerism in alcohol. Let me tell you beta. It exhibits chain isomers. Beta, it exhibits positional isomers. Even it exhibits functional isomers. Even it will exhibit beta tautomerism. Now let me explain you. I will give some examples of CI chain. I will give some examples of PI positional, functional, and then tautomerism. See beta, one example I want to show you. Here CH3, then CH2, then CH2, and CH2OH. Right? One more example I want to write here. Beta, CH3, CH, CH3, CH2OH. But if I'll ask you these two compound is having same number of carbon or not, you can count here. 1, 2, 3, 4. Yes, sir. 4 carbon. 1, 2, 3, 4 carbon. Hydrogen 3 plus 2, 5. 5 plus 4, 9 plus 1, 10. 3, 6, 7, 8, 9, 10. Hydrogen 10. Oxygen 1. Means both the compound are having a similar molecular formula. But you can see size of parent chain here 4 carbon, but a size of parent chain is here 3 carbon. And as you know beta, as the size of the PC changes, both the compound are what CI to each other. So I'll say compound number 1 and 2 are what chain isomers to each other. Second example beta, I want to show with the positional isomerism. Beta, it is a CH3, then CH2, then CH2, then CH2 and OH. Another case, well, right? It is a CH3, CH2, CH, then OH, and last by CH3. Both the compound are having same molecular formula C4H10O. But you can see how many carbon atom is in a parent chain? 4. How many carbon atom is there in a parent chain? 4. But if the size of the parent chain is same, but if the position of the substituent, functional group or multi-bolt bond changes, then they are the positional isomers to each other. You can see beta, OH is on first carbon atom, OH is on second carbon atom. As the position of the functional group changes, so they both are what? Positional isomers to each other. Functional beta. Point number 3. Do you know alcohol and ethers are functional isomers to each other? Fi to each other. Functional isomers to each other. Let me give example here now. But here CH3, CH2, 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 OH. This is the alcohol. And ether beta CH3, CH2O, CH2 and CH3. Diethyl ether and 1-butanol are both are what? Functional isomers to each other. Fi beta. They are the functional isomers to each other. Functional isomers to each other. But a tautomerism, example number 4. Do you know some unsaturated alcohol is there? But do you know what is a unsaturated alcohol? Best example we can say enol. What is the enol beta? You can see CH3, CH, double bond O, sorry beta, CH or C, double bond CH2 and OH. This is called as a enol. But a enol, that is a enol and keto. What is a keto? CH3, C, double bond O CH3. Unsaturated alcohol means this one. And this is called as a beta carbonyl compound. You know this carbonyl compound called as a what? Ketone. So unsaturated alcohol and carbonyl compound ketone, they both are what? They both are tautomers to each other. They are what beta? Tautomers to each other. So these are the few examples are there where the alcohol can show its isomerism. But now we will see about the structure of alcohol. What is the structure of alcohol? It's a very important structure of alcohol. But example I'll tell you. This is called as a methyl group, means CH3, and it is bonded with OH, called as a methyl alcohol. But I'll show you phenol. This is a benzene ring having alternate pi bonds, right? And this is bonded with the O and H group. Bonded with what? The OH group. One is a methanol, another one is a phenol. Just in this case, what does you see here? OH is bonded to the carbon, and this carbon is a what? sp3 hybridized. But OH bonded to the carbon, and this carbon is what beta? It is the sp2 hybridized. Do you know sp3 hybridized carbon is having only 25% of S character, but sp2 hybridized carbon is having 33.33% of S character. And one rule is there beta, greater the percentage of S character, greater the electronegative atom. And based on that we can say beta, these carbon of benzene ring is a more electronegative than the carbon of the methyl group. But a more electronegative means you can see that there will be changes in their bond length. But a bond length of this one, if you see carbon to oxygen, it is a 1.36 angstrom. And if you check the bond length between the carbon to oxygen of a methyl alcohol, but it is a 1.42 angstrom. Means you can see more the electronegative carbon is there, but more the electronegative carbon will pull the electron from the oxygen by pulling bond length between carbon of this benzene and oxygen decreases. Bond length decreases, bond energy increases. As the bond energy increases, reactivity decreases. In this case, beta, this carbon is a less electronegative than this carbon, so it has a less tendency to pull the electron. Hence, this carbon oxygen will have higher bond length than the carbon oxygen of phenol. Higher the bond length, less the bond energy, but less the bond energy, more the reactivity. If they will ask you about the reactivity between the methyl alcohol and the phenol, we can say methyl alcohol is more reactive than that of phenol. Reason it is there in between carbon oxygen bond and here with a carbon oxygen bond of a phenol, right? It is about this one. Second one, but as this oxygen, if you check here, it is having a two lone pairs, right, beta? And this oxygen undergo sp3 hybridization. Even these oxygen also having how many? Two lone pair, and it also undergoes sp3 hybridization. But in this case, में bond angle between carbon, oxygen, and hydrogen, if you check, it is a 108 point something. What we can say? It is a 108 degree we are getting, beta. But if you check the bond angle between carbon, oxygen, hydrogen in phenyl group, beta, it is more than that. Reason is what you know. Beta, oxygen bonded with a more bulky group and oxygen bonded with the less bulky group. But if the surrounding atom is more bulky, it will have more repulsion, and due to more repulsion, it will go away, and hence it will have a higher bond length. Phenol will have a higher carbon oxygen hydrogen bond angle than the methyl alcohol of carbon, oxygen, and hydrogen. So bond angle of methanol and bond angle of phenol in COH, phenol will having a higher bond angle than the bond angle of COH in the methyl alcohol. Reason beta, surrounding atom is bulky, it will have more repulsion, and due to more repulsion, bond angle get increases. It is the structure of the alcohol. But now we'll see the method of preparation of ethanol or ethyl alcohol. Ethanol or ethyl alcohol can be prepared from alkyl halide. But it can be prepared from alkyl halide. But as we know, in previous examples also we have seen alkyl halide when it treated with the aqueous alkali. Let me tell you, beta, CH3, CH2 and X. This is the alkyl halide. But whenever it is treated with the aqueous NaOH, but what is the difference between the aqueous NaOH and alcoholic NaOH? Aqueous NaOH will show the substitution reaction, but when it comes for the alcoholic NaOH, beta, it will undergo the elimination reaction. So aqueous NaOH, it will form nucleophile. What is the nucleophile produced by it, beta? That is a OH minus, and this OH minus will replace the halogen present over it, and we are getting here as a alcohol NaX came off. Not only that, beta, suppose if you take this is a alkyl halide, and whenever it is treated with the moist silver oxide, do you know what a moist silver oxide means? Actually, it is in this way. AgOH, they combine with a water molecule and form AgOH. OH will replace the halogen, and we are getting here as a CH3, CH2OH. Remaining silver halide came off. So, beta, ethyl alcohol or the alcohol can be prepared from the alkyl halide when it treated with the aqueous NaOH or the moist silver oxide. One more method is there. We can prepare it from the ester. Second method we can write, beta, this alcohol, beta, it can be prepared it from the ester, right? That will be called as a hydrolysis of a ester, beta. It gives rise to alcohol. I'll show you. Ester means it is a R C double bond O O R dash, right? This is called as a ester. But when it treated with the aqueous alkali means we can write KOH. But I treated with the aqueous alkali. What happened, in this case, this is a good living group. I repeat, beta, RO negative is the good living group. But as it came off, this carbon will get what positive charge. And on this positive charge, the nucleophile, what is that one, beta? We can say R dash O negative will take out the K positive. Right? Now, instead of that, 1 second. I'll show you the mechanism and then I'll tell you how this ester can be converted into alcohol. But for this conversion of ester to alcohol, what we are using, beta? Aqueous KOH. In this aqueous KOH, we are getting here as a RC double bond O. Then we are getting here as a beta O and then K plus remaining is that we are getting beta R dash OH. Beta, in exam, what they will ask you? Suppose the oxygen atom of these will be denoted as an isotopic form as a O18. But this O18 oxygen is present in the alcohol or it is present in the salt. So I will tell you better. In this case, the O18 present of the oxygen of the alcohol, not in the salt. Why? I'll show you the mechanism how it occurs. See, this is the ester. RC double bond OOR dash. Polarity will occur between carbon to oxygen. Oxygen will get negative charge, carbon will get positive charge. But it is a aqueous KOH, means it will produce the nucleophile OH minus where it attack on the carbonyl carbon. That means I am getting here RCO negative. It is bonded with OH and already we are having beta OR dash. As I said you beta, OR dash is a good leaving group. But when it leaves, it will form here as a RCO negative and in the OH beta. As it leaves, it form positive charge here. Positive and negative will make a double bond. So I'll write in this way where I got here as a carboxylic acid. But after getting the carboxylic acid, still we are having the salt. What is that? K plus is the salt present over it. But this K plus is the salt and OH ka O negative and H positive will ionize where it gives beta RC double bond O negative K positive we got the salt. Remaining what came off beta? H plus came off. You know R dash O negative came off. R dash O negative came off. What as the alkoxide ion is combined with H plus. I'll write it here. R dash O negative combined with H plus and I am getting here as a ROH. Suppose I will mention this oxygen as a isotopic form is a 18. So beta this is a oxygen 18. This is a oxygen 18. This is a oxygen 18 and this is a oxygen 18 phase. This oxygen 18 is always with the alcohol. So this is a completely mechanism I tried you to show how whether the oxygen of this 18 either it is present in the oxygen of alcohol or it is present in the salt. But I'll tell you this R dash O negative is a good leaving group and this oxygen 18 present at the alcohol but not at the oxygen of the salt. So what to say beta? Whenever this ester undergoes hydrolysis with a aqueous KOH, it gives rise to salt and it form here as a alcohol. So alcohol can be prepared from alkyl halide, alcohol can be prepared from the ester. So beta these are the two methods are there. This alcohol can be prepared from alkyl halide. It can be prepared from ester. Means ester on hydrolysis with KOH gives rise to salt and alcohol. But one more is that alcohol can be prepared from ester by its reduction. Suppose RC double bond OOR dash. We can call it as a ester. Ester when it undergoes reduction with a strong reducing agent like lithium aluminum hydride. This carbon with this R converted into alcohol, that is a RCH2OH plus it is a R dash and O, it will be converted into alcohol. Is we can say ester with reduction with a strong reducing agent like lithium aluminum hydride gives rise to alcohol. Not only that, if this ester will undergo catalytic hydrogenation, it will undergo with a catalytic hydrogenation. Catalytic hydrogenation means addition of hydrogen in presence of catalyst. Add the hydrogen here, where it will be converted into RCH2OH and ROH. See beta, preparation of alcohol can from the ester can be done in a three way. Ester with aqueous KOH, ester with the reduction with strong reducing agent, and ester with the catalytic hydrogenation converted into alcohol. Right? So till now we have seen two methods. Just take a screenshot. But after these two methods of preparation, the third method is that alcohol can be prepared from carbonyl compound. But I will give a complete concept of the carbonyl compound. What does it means and all. Listen here. For carbonyl compound के लिए, what is that? कि suppose if I am having a 1 degree alcohol ना बेटा, 1 degree alcohol on oxidation gives rise to aldehyde, and if I have secondary alcohol, then it on oxidation, but it gives rise to ketone. This is the concept. Even aldehyde also further undergoes oxidation and it gives rise to carboxylic acid COOH group. Ketone cannot undergo oxidation at a normal condition, but under drastic condition it can oxidize and gives mixture of carboxylic acid, and it is based on the Popov rule. Chalo, this is the part. Now I'll tell you the reverse order. See beta, aldehyde on reduction gives rise to 1 degree alcohol. Means aldehyde is a carbonyl compound. So I'll write beta here. This is the aldehyde. RC double bond OH. So this is called as a aldehyde. But what to do? Reduction. For reduction what we can use? Lithium aluminum hydride. It will be aldehyde on reduction. What it gives? Sir, it gives 1 degree alcohol. Can we say beta RH2OH are called as a 1 degree alcohol. Second part beta. Ketone on reduction, it gives rise to 2 degree alcohol. What is a ketone? You can see here. It is a RC double bond OR, and this will be called as a ketone. But a ketone, this one on reduction, it gives rise to 2 degree alcohol. And do you know 2 degree alcohol can be written in this way. This is called as a 2 degree alcohol. For this special reduction के लिए even a sodium borohydride called as a weak reducing agent is also sufficient. But one more possibility is that carboxylic acid can be converted into alcohol. Carboxylic acid on reduction can be converted into alcohol. What is that? I'll explain you beta. Carboxylic acid means it is a RC double bond OH, and this will be called as a carboxylic acid. Beta it on reduction. So it on reduction with two step, lithium aluminum hydride, and second step beta hydrolysis in the acidic medium. It will be converted into 1 degree alcohol. 1 degree alcohol, because ketone cannot undergo oxidation at normal condition. Only under drastic condition it undergo oxidation and it gives rise to mixture of carboxylic acid. But as we consider only one carboxylic acid, so this carboxylic acid on reduction converted into 1 degree alcohol. But this is the concept, and this concept we have to apply for the preparation of a 1 degree, 2 degree, even 3 degree alcohol. In place of R, I am going to put the CH3. Then it becomes C double bond OH, but it will be called as an acetaldehyde. Second one, in place of R, I want to put the CH3. Then C double bond O, CH3, 2-propanone called as a acetone. Third one, in place of R, put the CH3. Then what we have it as C double bond O, OH, and this will be called as a what? Carboxylic acid. But it undergo reduction. Reduction can be done in presence of lithium aluminum hydride. What it gives? 1 degree alcohol. 1 degree means it is a CH3. But this C double bond O converted into CH2 and OH. We got 1 degree alcohol. But here it on reduction with the NaBH4, where it will be converted into what beta? CH2, I mean CH and OH. So this is a CH3, then this is a CH and this is a OH. I got CH3. This will be called as a 2 degree alcohol and this will be called as a 1 degree alcohol. Carboxylic acid beta, it will be undergoing reduction with the two step. First step may lithium aluminum hydride converted into aldehyde, and second step may beta hydrolysis in the acidic medium, where that aldehyde converted into alcohol. So CH3, CH2, OH called as a 1 degree alcohol. So did you understand beta? Alcohol can be prepared from the carbonyl compound. It may be aldehyde or ketone, and even you can see carboxylic acid containing C double bond O group is also called as a carbonyl compound. Means carbonyl compound means compound which is having a carbonyl group. C double bond O group, C double bond O group, C double bond O group called as a carbonyl group, where it converting this aldehyde to 1 degree alcohol, ketone to 2 degree alcohol, and carboxylic acid to 1 degree alcohol. Right? Method of preparation of the alcohol. But a fourth method is there. We can prepare the alcohol from alkene. From alkene. Let me explain better alkene one example. This is a alkene CH2 double bond CH2 and we are adding the water on it. Addition of water to the alkene can take place in presence of an acidic medium on heating. But the water is having two parts H plus and OH minus. One H will be added here and one OH will be added here and we got the ethyl alcohol. But we'll see the mechanism behind it. What is the mechanism here that alkene can be converted into alcohol? Step number one, we can say beta here formation of carbocation. Formation of carbocation. You can see beta this is a carbon double bond carbon and these are the four hydrogen present over it. Reaction take place in presence of acidic medium. Obviously H plus is there. But this is a pi bond. It shifted to this carbon. It will get negative charge and this negative charge will take out the H plus where we are getting beta in this way is C then H H positive charge over it and these are the three H we got. So this will be called as a carbocation. But remember whenever in the mechanism carbocation is formation of carbocation, whatever but a rearrangement takes place. Means if 1 degree carbocation is there, if possible it may undergo the 2 degree. It may possible to undergo the 3 degree carbocation. So formation of carbocation. Step number two beta attack of nucleophile over it. Step number two that is a attack of nucleophile on the carbocation. See beta this is a carbocation we are having CH and positive charge but it is bonded with the CH3. What is a nucleophile? You know water is a nucleophile. I'll write the water in this way. It is a water which is having its lone pair and it will attack on the carbocation. But as it attack on the carbocation, how it look like? It is a O bonded with H and H. Then again we are having a 3 hydrogen present over it and now this oxygen will get the positive charge. Right beta? So attack of the nucleophile on the carbocation and we got protonated alcohol. It will be called as a protonated alcohol. And the last step beta called as a deprotonation. What is meant by deprotonation? D means removal and removal of proton. But a removal of proton means again CH3, this is a O, then H and then positive charge and it is bonded with the 3 hydrogen. But still we are having a one more water molecule. It will take out one H plus from here and we are getting that is a CH2 bonded with OH and CH3 plus hydronium ion. You can see beta CH3 CH2 OH as a alcohol we got in the 3 step. So it is a one method is there. But one more example I will take. I am having a unsymmetrical alkene and whenever I want to add the water molecule in presence of dilute acid beta, it will follow the rule called as a Markovnikov rule. But in this Markovnikov rule mein, what is that? Water will ionize as H plus and OH minus. But a Markovnikov rule says that positive part of the attacking reagent attaches itself to that double bonded carbon where it will have more number of hydrogen. So when H will attack here, it form the carbocation. I'll show you CH3, then CH, positive charge, CH2 becomes CH3. But it is a 2 degree carbocation form. If we want to rearrange 2 degree to 3 degree, rearrange it. But here, there is no possibility for the rearrangement to become 2 degree to 3 degree. So leave as it is. Then another part, what is that beta? OH minus and these OH minus will attack on the electrophilic center and it form CH3, CH, CH3 and OH called as a 2-propanol. Means I want to say beta, whenever you are adding the water molecule to the unsymmetrical alkene, it always follow Markovnikov rule. It form the carbocation. If possible, rearrange it, and then attack the nucleophile, we'll get the final product. So beta, these are the some four methods we have seen. Again, remaining four methods, total 8 methods are there. Video length is going it's a very long. In my next video, I will upload beta the remaining four part of the method of preparation of what we can say beta alcohol, right? Thank you very much.